Hello, so if you've done integration by parts before, you've probably seen this integration by parts formula, uv minus the integral of v du. Well, in this video, we're really going to talk about what integration by parts does at the heart of it, as well as how it relates back to product rule differentiation from calculus A. So we're really going to show where the derivation of this integration by parts formula actually comes from. And to do this, we're going to start off by differentiating a product of functions. So if we take two general functions, say f and g, and we multiply them together, take their derivative, we use the product rule, and we get that's equal to the derivative of f times g plus f times the derivative of g itself. So we get f prime g plus f g prime, essentially. And well, at this stage, there's no integration anywhere yet, but we're actually just going to go ahead, integrate what we just did for product rule. So taking the previous product rule line, we're going to go ahead and just integrate both sides in a moment. Okay. And we're going to integrate both sides of this equation with respect to x. There's going to be some little mathematical manipulations we do, some algebra in a couple moments, but I first want to draw our attention to two quick things. The first thing, if we look at this integral on the left-hand side, this is an integral of a derivative. Again, we're taking the derivative of that product of functions, f and g. So when we integrate a derivative, by the fundamental theorem of calculus, that'll just pass us back that function itself. So this left-hand side, this thing's actually going to be equal to f of x times g of x. Okay, that's one thing so far. That's on the left-hand side of this. The right-hand side, well, the only different thing that we're going to do is, since we have an integral where we have two terms being added or subtracted together, we're just going to break it into two separate integrals. So that right-hand side, we're going to turn into the integral of f prime g plus the integral of f of x times g prime of x. So we haven't done anything fancy on that right-hand side, just use properties of integrals to put it into two separate integrals. Now, the next step, we're going to start rearranging some stuff. As in, basically what we're going to do is take this first integral and just subtract it on both sides to get it onto the left-hand side of this equation. So let's go ahead and do that. So we'll have f of x times g of x, and then after we subtract that first integral, we'll get minus the integral of f prime of x times g of x dx. And that thing will still just be equal to that remaining integral that was on the right-hand side. So far, we've done product rule. We've just integrated that general product rule. We use the fundamental theorem of calculus just to give us the f times g on that left-hand side, and then we subtracted one integral onto the left-hand side. We are actually very, very close to getting this integration by parts formula. The next thing we're just going to do is just rearrange this equation a little bit to get this closer to what we're normally accustomed to seeing. Literally, I'm going to take what's on the right-hand side, move it to the left side, and what's on the left-hand side, and just move it onto the right-hand side. Now, what was the purpose of that? Well, what I want you to think about is this left-hand side integral. This is kind of like the integral that we're given at the beginning of a problem, told to integrate it, find the antiderivative of its integrand. This is basically what we're starting with in a problem. And if we choose to do integration by parts on something, we choose to differentiate something, that part we call u, and integrate the other part, the part we call dv. Well, in this integral on the left-hand side, we're going to define a u and a dv from it. We're going to call that f of x our u portion, and we're going to call that g prime dx, that will be our dv. So if we just do a quick aside for a moment, what we're going to see is we have u as f of x. Du will now be, well, the derivative of f of x will be f prime of x, and we get that dx to go along. Now, if we have dv is equal to g prime of x dx, to get v by itself, we integrate both sides, and we get that's equal to, v is equal to, just g of x. Since the first line, we had the integral of a derivative, so by fundamental theorem, that just passes us back that function g of x. Now what you notice is on this right-hand side, we have all of these characters there. So first, if we look at this u, anywhere there's just an f of x function, we call that u. Anywhere there's a g of x function, we call that v. And now anywhere there is I'll just change this color so it helps us a little bit. Anywhere there's an f prime of x that can be grouped with a dx, we call that du. And if we look at that integral, we have an f prime of x and a dx, that is our du. So actually on this right-hand side, what we actually have at this junction is our integration by parts formula. This right-hand side is indeed giving us that the integral of u dv is equal to uv minus the integral of v du. So where this integration by parts formula actually comes from is from a product rule differentiation and integrating it and just rearranging some of the terms around. I hope this has shown that relationship between integration by parts and a product rule differentiation.